So, a few years ago, physicists actually managed to take a photograph of a black hole.
And that's still one of the most insane sentences in modern science. The entire point of a black hole, if you haven't realized, is light can't escape it. It's a black hole. And somehow, still, humanity has found a way to take a picture of it.
Like always, thousands of researchers, observatories on I don't know how many different continents, decades of theory, and they all lined up for this spectacular event to happen. And in that same news cycle, more people online were talking about a missed penalty for some reason.
Yeah, that's brutal for the astrophysicists out there, right?
Yeah, it's so genuinely strange. We've split the atom, we've landed on the moon, mapped our whole human genome, and every 4 years humanity just collectively decides that the most important object on earth is a football, and that the most important action is the kicking of said ball. And it's not even a special ball.
It doesn't even do anything, it just sits there until someone kicks it. It's not like,
Yeah.
it's not like a remote controlled ball, RC car or something like that.
Right. And yet entire countries change mood on basically where that ball ends up. So today's episode is basically why that ball matters and everything around it, right? And it turns out that the answer the answer to this question runs through fluid dynamics, probability, evolutionary psychology, game theory, and even information theory.
So let's start with the ball then, because you brought it up like it's personally wronged you in some way. Has it like stolen your curry jersey or something?
No, no, no. I mean, it kind of does wrong people, though. That's the whole point, right? Take the example of like a curling free kick. The ball spins, and the spin then drags a layer of thin air around it. And on one side, that dragged air adds to the airflow that is coming at the ball, so it speeds up. And faster air basically means lower pressure. Just for example, and on the other side, the ball fights the airflow and it slows it down and pressure goes up.
And high pressure pushes towards low pressure. So the ball gets shoved
Yeah.
sideways. And that's throughout its entire flight, right? So from 25 yards out, a well struck free kick, say from a given player, can drift more than 3 feet off a straight line. And the keeper reading the initial trajectory is reading the wrong shot entirely. Because you can understand that intuitively, because you can see the bend across so many of these famous football goals or these famous free kicks.
Yeah, yeah. And a very common one that most people don't see coming through is something called a knuckleball, right? And it happens due to this phenomenon in physics called the drag crisis. I know, extremely dramatic.
Yeah.
Um, but yeah, it basically makes free kicks look like they have a mind of their own.
The ones that just wobble with basically spin are the ones that we're talking about. Like, it's crazy. Like, understand how physics like defines such a thing, and that's exactly why this small section of that, like this, the balance between the smoothness of the football and the way it's kicked decides that area of the drag crisis.
Right. Every object moving through air has a thin boundary layer of air that is clinging to its surface, right? And at low speed, that layer flows relatively smoothly, and at high speed, it becomes uh, almost fully turbulent. But in this narrow band between something like 50 to 70 miles an hour or something, this layer basically can't decide whether to stay uh, laminar or turbulent. So basically, it flips back and forth between laminar and turbulent in random patches and on different parts of the ball at the same time, which is basically what causes the ball to appear not to spin, if that makes sense.
So that makes sense. Yeah. So the drag force is also flipping out around randomly, and that means that the ball wobbles with no fixed direction. And again, this is not a skill issue for the keeper, okay? It's not like that they acted half a second too slow. The trajectory is genuinely unknowable in advance because it's being decided by microscopic turbulence. Now, if the keeper had, for example, a like a an omnipresent understanding of every single air molecule that the ball's going to pass through and the surrounding air molecules that are going to be affecting the ball's trajectory, then, and if he had a supercomputer of a brain, then he could probably decide on where the ball is going to land up. But that, in its essence, is such a wild thing to exist on a football pitch, if you think about it.
Yeah, and what you talked about is just compute, right? That is just for him to know where the ball is going to end up. He actually has to make the jump to go to that place. Uh,
And
and
save the ball or catch
yeah,
the ball, yeah.
uh, and like a very funny part of this whole problem is that every time FIFA redesigns the official ball for the World Cup, a lot of players complain that it moves differently, and
Yeah.
most of them are right because
It does
essentially,
move differently. Simple as
yeah,
that.
changing the panel count, basically the number of hexagons and pentagons on the football, right? Those are panels. So if you change the panel count or say the
The
depth of
shape
this,
of the panels.
yeah, the shape of the panels or the depth of the seam that you know is in between the panels, it shifts where this chaotic zone that we talk about, where that zone sits. That
Exactly. So
basically
the
gets affected.
physics, yeah, so the physics inherently stays the same, except the chaos is relocated to a different speed. So the goalkeeper still don't know, and also it depends on ball to ball, right? Because each ball has its own zone,
Yeah.
and then each ball has to be differently calculated by the goalkeeper. So it's even more chaotic.
Okay. Uh, moving a little bit off the ball, here's like a fact that sounds wrong, but it holds up mathematically somehow. The format of football basically guarantees that the best team won't always win. And that's not a flaw in the sport itself, but it's structural to it.
And that's kind of upsetting. But the mathematical part that you're talking about is something called the Poisson distribution. And I don't know if I'm pronouncing this name right, but Simeon Dennis Poisson, whatever his actual pronunciation is, described it in 1837 for completely unrelated stuff. But it models rare random events that are scattered over time, which is surprisingly exactly what a goal is. It's so random and so unpredictable, and it can happen at any given point during the 90 minutes plus extra time and all that. So it's kind of like the butterfly effect. A goal needs a long chain of things to go right or a long chain of things to go wrong. Stuff like that, like from another team having an own goal, for example. But any one failure in that like chain kills the chain because you need to have that um like flow with the goal because you just don't score goals out of the blue from one end of the field to the other. That's extremely rare. So goals inherently are also extremely rare. Um, Even if you don't score them from the other side of the field, from your half.
And I think I think we can estimate that a typical match would average around like maybe two and a half goals in total. So, roughly around 1.3 goals per team. And if you run that through this Poisson model distribution that you talked about, the single most likely outcome for a team is scoring exactly one goal. But scoring zero sits around 27%, which is quite wild. And scoring three or more is at about 10%.
It's a huge spread for something centered so low. And that now when we think about it, that's the entire problem. If you compare it to basketball, where an NBA team scores something like 100 points a game, that's 115 scoring events, each with its own randomness. But once you stack that many together, the law of large numbers kicks in. Basically, since you have a larger sample size, the luck cancels out because the samples just average out because you can't get unlucky 100 times in a row. It's just really
I mean,
unlikely,
you
you know?
can, it's just extremely unlikely for that to
Yeah,
happen.
yeah, it's just really unlikely. Yeah.
And the better team's edge over here compounds reliably. But in football, it only gives you two or maybe three scoring events in total, right? And a team that's genuinely 70% likely to win still loses around three times out of 10 because that's just a weighted, that's just what a weighted coin does, right? Probably.
Yeah, and that's why in football, in the World Cup, one deflection can become a national tragedy.
Yeah, the hand of
And
God.
that leads into every single prediction model. And that's why every single prediction model that predicts, say, oh, Argentina is going to win the World Cup, oh, Netherlands going to win the World Cup, X team is going to win the World Cup, they get dragged online after the tournament saying that, oh, these supercomputer predictions that never seem to land are just bad. They're just plain wrong, apparently.
And the models aren't wrong, right? People just
Yeah,
misread what probability actually means. If a model says that, for example, a team has a 19% chance to win the whole tournament, it means that if you ran like a simulation of the whole World Cup 100 times, then 19 out of those 100 times that particular team will win. But it says nothing specific about this particular run that we are simulating it in. And we can only see
right.
it in advance.
Exactly. The World Cup goes once and it counts only one winner. So that one tournament in 2026 right now that we are going through is one sample out of that distribution of 100. So even if it's a 1% chance for team X to win, that team still has a chance to win. You cannot rule that out because let's say it's that probability that that one given event happens this year. No one knows. It's kind of like Doctor Strange and Thanos, when Doctor Strange said there was only 1 in 14 million chances or like simulations of probability, or like 1 in 14 million possible outcomes where the Avengers would
Yeah.
win. And this was that one outcome that they somehow won. So it's like that. So you can never rule anything out with math.
Yeah. It's shocking to watch, but not actually evidence that any sort of forecast was really broken. And that's the part most people skip. A 10% event happening isn't proof that the model failed. It's just proof of the fact that 10% events occasionally happen, which is the definition of what 10% means.
Yeah.
There's also like a structural limit that no model gets around, which could be, modeled by the difference between, say, climate and weather. Because a climate model can tell you, what the average temperature around a certain period would look like, but it can't tell you if it rains at 3 p.m. on a particular day or something like that. That's what weather does.
Yeah. And in general, your like outcome can land anywhere. For example, Germany in 2018 were the defending champions. They were given something like a 17% chance of winning the entire tournament by most of the like
Pundits.
flagship model. Yeah. However, they had a group stage exit. That was a 1 in 50 event. Shocking to watch, but not actually evidence that the forecast was broken. And as you said, the 10% event isn't proof that the model failed. It shows that actually they happen, because if it doesn't happen, it would be even more surprising because it is expected to happen 1 in 10 times. If it doesn't happen 1 in 10 times, then that's surprising. So similar to your climate and weather example, the football forecasting has the exact same ceiling because most models rank underlying quality fine, but they can't model like a margin in a handball in 65th minute and the goalkeeper is having the night of his life. Those aren't noise sitting on top of the data. They are the data because that's how football is. Anything can happen at any given point.
Okay, okay. We've talked a lot about, data and probability and stuff. What if we zoom out from the pitch for just a second? Because I feel like the atmosphere that surrounds you, especially the crowd, right? It has something to do with the outcome of the game that could be equally strange. 80,000 strangers are chanting in unison with zero uh with yeah, with zero unifying conductor.
Yeah. So that's one of my favorite bits. Get 80,000 people to agree on anything else, you'll need a week and hundreds of mediators. But if you put them in a stadium, despite them being supportive of different teams, they sync up in about 4 seconds.
How does that even propagate?
Mhm. It's all vibes, because nobody's broadcasting a signal like to everyone at once. Like you said, there's no universal 80,000 people conductor or orchestrator.
Yeah.
Each person just watches a handful of people immediately around them and copies them. It's kind of like a sound wave propagating through nearby particles, push other particles, and that wave keeps going forward. So someone nearby, for example, stands and raises their arms for the wave, and you do it a beat later. The people near you see you do it and they follow, and it spreads outward like a front moving through a crowd, like a wave front.
Hmm. That's that sounds a lot like, fireflies syncing their flashing together. And
Oh,
the
yeah.
surprising part is that the underlying mathematics model is essentially the same. And that is why coupled there's this thing called coupled oscillators which have no leader or no shared clock, right? They're just local clocks that are syncing into rhythm. So you can consider each firefly to have a clock of its own, but all fireflies are lighting up when their local clocks sync up at the same time. And the same structure shows up in how neurons fire across our brain as well. And researchers have actually measured stadium waves moving at around 12 meters a second, and they almost
Ooh,
rotate
yeah.
clockwise from above, which is very interesting.
Interesting. And is there like a rule for this that they almost always rotate clockwise from above?
No, I wouldn't say there's like a particular rule at all. It's just more of an observation, right? It's a tiny statistical bias in how people tend to start behaving, and they tend to start the wave that gets amplified once it's moving. And the wave itself has no idea of the direction that it's going in. It just ends up going that way.
Yeah, just a quick thought experiment. If you're sitting in the stadium and if you want to start a wave, would you look at your left or your right to start the wave? I would say most people would say left, right?
Hmm. Yeah.
Because
Yeah.
because that's what the bias
Logically.
gets into, right? This tiny statistical bias that allows you to propagate that wave. And this is such a beautiful and clean example, of order showing up with nobody actually designing it.
And there's also a reason that's linked to game theory as well. And that's basically how the stadium feels different from watching it at home, as compared to watching, in the stands actually, uh, when you're in the
With
stadium.
those 80,000 people,
Yeah, with
79,999
yeah,
people.
yeah. And basically it says that knowing that your team scored isn't really enough. You need to know that everyone around you also knows it, and that they need to know that you know it as well. And it's just this kind of circular thing that is stacked infinitely.
Yeah, so a goal alone in your room is just information. But a goal in a packed stadium is information plus instant visible proof that 79,999 other people just received the exact same information at that same moment because they're in the stadium with you. That confirmation is doing most of the emotional heavy lifting. And that's why the same broadcast at a viewing party hits differently than watching solo on your phone, for example, at home.
Yeah, yeah. Okay. Now I feel like we should also talk about why we care so much about these 22 strangers who are playing
Plus
against
substitutes.
yeah, plus substitutes and the manager and everything, who are who are playing their hearts out and spilling all kinds of stuff onto the field. Yeah, why do we even care about that? Let's discuss
That's a
that.
really that's a really interesting question. And that goes about 400,000 years. We're traveling back in
Right.
time a long, long time ago, back when Pratham was just a child. Humans,
Right.
right. So humans at that time lived in groups of maybe a few dozen. And being in a group wasn't optional, it was survival. If the group did well, you did well. If the group didn't do well, either everyone in the group died, or if you're not in the group, you just die alone. Simple as that. Because you cannot stand those wild animals without a group. Simple as that.
Nice picture to paint. So evolution would favor people who actually felt something when the group won or lost. So like, a kind of a group emotion, something like that.
Interesting. So that's probably because emotional investment is far more efficient as a cooperation mechanism than running a mental cost benefit calculation every single time. The feeling has replaced the math. And as we've spoken about this before, there's a classic game theory setup here, the prisoner's dilemma.
Yeah.
And if you have a single round, the most rational move is to deflect for your own selfish needs.
Yeah.
But over time, if you have multiple samples and you play repeatedly as a game with the same people and people remember your previous moves and previous actions, then cooperation becomes the clear win, the stable strategy. And a guy called Robert Axelrod actually proved with computer tournaments back in the 80s that tit for tat, for example, I think based on a Veritasm video, was the
Yeah.
best
Yeah.
performing algorithm because it cooperates first. It always starts with a cooperation. It punishes your betrayal. And if you like cooperate again when the tit for tat algorithm is deflecting, it'll forgive you given that you have accepted your mistake, and then both of them can cooperate indefinitely after that, I guess.
Yeah. So basically, what Arnav's trying to say is that this algorithm starts off by cooperating and then it mirrors
Yeah.
every move that you had made last round.
Previously. Yeah.
Exactly. But another interesting nuance to this is that in the second iteration of the tournament that was played, uh, an algorithm called tit for tat with 10% generosity actually performed far better than tit for tat itself. And that's basically like with a random 10% probability, tit for tat would just cooperate instead
Rather
of
than deflecting.
mirroring whatever had happened before. And that turned out to you know perform a little bit better than tit for tat itself. And it's because uh, over like a long scale of time, humans are much more likely to cooperate. And if you are the only single defector within, a sea of cooperators, ultimately you're going to lose. And what the video also speaks about is that even a very small group of cooperators within a very large group of defectors,
Just, yeah.
the yeah, if that's the case, then a small group of cooperators can also expand their population very quickly because
It's kind of like a
cooperation.
bacteria multiplying,
Yeah,
those cooperators can expand and take over the defectors and make
cooperation
them
inherently
cooperators with them.
generates more
More
whatever
cooperation.
resources or score than non-cooperation. That's yeah, that's quite interesting. So yeah, coming back to what we were talking about, right? So
And
yeah, tit for tat, cooperate first, punish betrayal, and forgive finally. And evolution didn't just give us the logic for that; it also gave us something called oxytocin, which is the bonding hormone, and it spikes in group settings and shared emotional moments, and it locks in cooperation chemically before anyone consciously decides anything.
so a World Cup match is basically an event where a lot of oxytocin is released because a lot of people are in, as you said, shared emotional moments with goals being scored, goals being missed, penalties being taken, fouls being had, and a lot of other stuff. Like everyone being angry at the referee, both sides collectively shouting and yelling, all that stuff.
Pretty much. And the strange part is that we feel that uh, tribal pull towards people we've never literally met in our lives, and it's because we are bounded by uh, a shared story and not blood, right? So countries are stories that everyone agrees to believe in. So you think about it, right? You will probably never really meet every single person in your country, even if you are say something like the prime minister, right? But you still feel a sense of connection to everyone who's from your country because you share that same characteristic of a sense of belonging to your particular country. So eh, there are a lot of other, figments of imagination that we have made, like money or universities, etc. And for those 90 minutes that your nation is uh, giving it giving it their all on that field, your nation stops being a constitution and it just becomes 11 specific people on that field, and every person in your country can relate to those 11 specific people, which is pretty cool.
Yeah, one thing I want to mention is you just casually drop that money and universities are just abstract thing. Nice one. We should speak more about that later. But yeah, the whole idea is that this abstract thing of football slash soccer for the American viewers, it becomes a felt thing. That's the whole transformation that happens underneath all the noise. Science, for example, can explain the curve of the free kick using Magnus effect, the chaos and the upsets, the wave in the crowd, and the reason you care about this in the first place. But the improbability of any one tournament isn't a flaw in the system. It's the entire point.